The last thing to talk about in this chapter is power, and power is the rate of doing work. Power is given in watts, those are the units, and in this equation we have work done divided by the time interval will give us the power. Another way of finding power is to view the instantaneous power, and that comes from the derivative of the work with respect to time. So if the work is some variable amount of work done over some course of time, you take the derivative to find the instantaneous power. Now there's another way to find the power. This one takes a little bit of derivation. So we start off with power is equal to the derivative of work with respect to time. We remember that work is equal to F times the cosine of theta. We'll use phi in this case just because. We were taking the dot product with the work across the displacement. So the displacement would be dx, and then we still have dt. So I replaced the work with f dot dx. This right here is f dot dx. Two vectors. When you take the dot product between the two vectors, you have to get the cosine of theta. So f dot dx. So we get the cosine of theta. Now we have that the power is equal to f cosine of phi. And a little bit of rearranging, we're going to have dx over dt. You guys know that displacement with respect to time, the derivative of displacement with respect to time is equal to velocity. So now it looks like we have f cosine phi times the velocity. Or finally, we just have that the power is equal to f dot v. Since we have f v cosine of phi, that is the same thing as saying f dot v. So if we take the dot product of the force with the velocity, we are also going to get the power. You guys don't have to worry too much about that derivation, but you should know that equation. Force dotted with the velocity is also equal to power.